Hello everybody and welcome back to another visual pattern challenge. Today we've got rubber duckies. Here is step 1 of our pattern, here's step 2, here's step 3, and your challenge is to predict the number of duckies in step 4. If you can do that, can you predict the number of duckies there would be in step 43? And can you come up with an equation that could be used to predict the number of duckies in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. All right. The first thing I'm noticing about this pattern is it seems to be growing rapidly. So I'm going to guess this is something more than a simple linear equation. But let's see if we can visually see what's going on to make a prediction about step 4. I guess one thing I notice is that on the bottom row is always one shorter than the other row. And it goes, well, this bottom row goes 1, 2, 3. So on the bottom, I would expect there to be a row of 4. And then what's left looks like a square every time. Yeah, so this is a 2 by 2 square, a 3 by 3 square, a 4 by 4 square. So I would expect a 5 by 5 square of duckies. So 5 times 5 would be 25 duckies, plus 4 more would be 29. So that's my prediction for step 4, 29 duckies. Let's analyze the numbers here and see what kind of a pattern we're really dealing with. So I'm going to put the step number in a chart and the number of duckies. Okay, so in the first step we have 5 duckies, and this is 9, 10, 11 in the second step. And in the third step, that's 16, 17, 18, 19. And in the fourth step, we are predicting 29. To analyze these numbers, we're going to subtract. We're going to find the difference between each step. So 11 minus 5 is 6, 19 minus 11 is 8, and 29 minus 19 is 10. And we're not getting the same number in each step. That means it's not a linear pattern. If this is a constant, it would be linear. Since it's not, it's not. We can go further. We can take the difference of the differences. 8 minus 6 is 2. 10 minus 8 is also 2. When you get the same number there, when you have a constant in those second order differences, that means it's a quadratic pattern. So somehow we've got x squared in here. And that actually makes a lot of sense with our visual intuition from the beginning, right? Because we had these squares and then something left over. Here it's a 2 by 2 and then a 3 by 3 and then a 4 by 4. So it looks like the size of the square, the dimension of the square is always one more than the step number. So if I were going to write that out, I'd say let's take the step number and add 1 to it and then square that. So for step 1, this would be that 2 by 2 square. For step 2, this would be that 3 by 3 square. And then we've just got this piece left over, and that part is pretty easy. It's 1 here, 2 here, 3 here, so it's always the same as the step number, and we represent the step number with x. So this should be our equation, and you can just leave it in that form if you want to. It corresponds to what we see up here in the pattern, so it's kind of a useful way to express this. If you want to, you can also FOIL all of this out. Let's see, what would you get? So that'd be x squared, and you'd get 3x plus 1. So this is the same as this. It's just another way of expressing it. So let me write this equation down here. We'll test this, but I'm pretty confident about this, so I'm going to write it down right now. But let's test it with a couple of these steps. So x squared would be 1 squared. X stands for the step number, plus 3 times x, or 1 here, plus 1. So 1 squared is 1, plus 3 more is 4, plus 1 is 5. Yeah, that's how many we get in step 1. Let's try step 2. That'd be 2 squared plus 3 times 2 plus 1, and that'd be 4 plus 6 plus 1. That is 11. Yes, this seems to be working. If you want to test this with step 3 and step 4 to verify our 29, go ahead and do it. I'm confident in this. So the last thing I'm going to do here is get how many in step 43 by simply putting 43 in for x in this equation. So y equals 43 squared plus 3 times 43 plus 1. So let's see, 43 squared is 1,849, and 3 times 43, that's 129, and then plus another 1. So what are we getting here? 1,979? Might want to double check that, but that's what I think it is. 1,979 little duckies in step 43. Well, that was a kind of a difficult one. How did that work for you? Did you get 29 for step 4? Did you come up with this equation? Let me know. Thanks, everybody.